For section 6.6, we're going to be looking at the general approach to factoring, whether we have a binomial, a trinomial, or more terms. So to begin with, we're going to start with a binomial, which tends to be the hardest. So binomial, first thing we got to think of is, what if we have a greatest common factor? In this case, in example 8, I can divide both of these by a 9. So I'm going to factor out a 9. Once I divide both by 9, I'm going to have p plus 5. There's nothing else I can do to my inside of the parentheses, so that is all I had to do. For example B, my greatest common factor in this case is 4mp. So let me divide both by 4mp. And I'm going to have 2mp plus 1. Looking at example C, this whole thing is a term. This whole thing is a term separated with a minus sign. I'm going to factor in this case an a plus b. I can see that's what I have on both. If I cancel it out, right, if I factor it out, I'm going to have 5x minus y. So it's going to be my other factor. So that's as simple as just a greatest common factor. Sometimes it's not as simple as that. I look at my example A. I cannot factor a greatest common factor. However, because my exponents of my letters are to the second power, I'm going to try to write everything to the second power. I'm going to write this as 8m all squared minus 3n all squared. So I have the difference of the squares. Now what I have to write, my factors in this case are going to be 8m plus 3n and 8m minus 3n. So one of them has a plus, the other one has a minus. Now looking at example B, first thing, remember, greatest common factor. Cannot take a greatest common factor by my p's to the third. So I'm gonna try to write everything as to the third power. So I have 2p to the third minus 3 to the third. Now, because the difference of the cubes, the first parentheses will be 2p minus 3. You guys can see where the 2p minus 3 come from. I just ignore the cubes. Now, my second parenthesis is going to be long. For my first parentheses, I square the first term. So 2p times 2p, that gives me 4p squared. I squared the last term, negative 3 times negative 3, and I'm going to finish with a 9. So that's how I know how I'm going to start it, how I'm going to finish. Now my middle term, because my first parenthesis has a minus, I always have to go with the opposite sign. So I'm going to do plus. And I multiply the two terms of the first parentheses. 2p times 3, that gives me 6p. That's my factoring on that one. And then I got to see my second parentheses. I can see here if I can factor it. I'm going to try perfect squares. But this one's not going to work because I get 2p. I get 3 here. Multiply 2p times 3 does not give me the half of the middle term. So I'm just going to leave it at that. Now, looking at example C, I have cubes as well. Once again, I'm looking at the exponent of m. I'm going to write everything as to the third power. I'm going to write 10m, all of it to the third, plus 1 to the third. My first exponent will be, my first factor, will be 10m plus 1. Notice I just ignore the cubes. My second parentheses, I square the first term. 10m times 10m will give me 100m squared. I squared the last term, so I'm going to finish with a 1. Now, because it's a plus sign, I'm going to do minus, multiply the two terms. That's what's going to give me my middle term. Now, looking at D, my exponent is to the second, so I'm going to try to write everything to the second. I have 5m to the second plus 11 to the second. For squares, it has to be strictly a minus. I cannot do plus. So this one I cannot factor it. So I'm just going to have 25m squared plus 121. I cannot factor it because of the plus sign. When it is to the cubes, I can do minus like I did on B, or I can do plus like I did on C. But when it comes to squares, it has to be minus. Now, in other cases, what if we have three terms? We're going to start with the special cases. What if I have a perfect square? Perfect square means I'm going to have the same root, or the same factor, twice. The way we're going to check that is get the square root of the first term. That gives me a p. Get the square root of the last term. The square root of 25 gives me 5. If multiplied, those two give you half of the middle term, so 5 times p is half of 10p, you do have a perfect square. Respect the sign from the middle, so I'm going to put a plus in between, and I'm going to say my factor is p plus 5 twice. Same thing with example B. Get the square root of the first term, 7z. Get the square root of the last term. Multiplied, it is equal to half of the middle term. So I'm going to respect the sign of the middle. I'm going to do a minus, and I have 7z minus 3 twice. Now I'm not going to do the same for example C, because I cannot get the square root of 6. So I'm just going to think of the diamond, the x thing. I'm thinking of two numbers that multiplied equals -6, but when I add them is equal to -5. My numbers will be -6, +1, because my first number, my leading coefficient, number in front of the y squared is a 1, right? When we don't see a number, it is a 1. I'm going to go straight to parentheses, and I'm just going to write y minus 6, y plus 1. I always do half of the first exponent. That's why I did y to the 1 on each. Now looking at example D, I think of perfect squares. This case is not. So I'm thinking now of two numbers that multiplied equals -12, but when I add them is equal to -1. My numbers will be -4, +3. Because my leading coefficient is not a 1, this is just how I'm going to split my middle term. So I'm going to do 2k squared minus 4k plus 3k minus 6. Let me take a look at the first two terms. I can factor a 2k out, and I'm going to have k minus 2. Looking at the last two terms, I can factor a +3 out, and I'm going to have k minus 2. Now, to finish this, my factors will be k minus 2 and 2k plus 3. Now, my example F, I'm going to start by dividing everything by 2. I'm thinking greatest common factor. I'm going to make my numbers smaller. So I'm going to divide everything by 2. So I should have 14z squared plus 3z minus 5. So now I'm looking for two numbers that multiply equals -70, but when I add them is equal to 3. Thinking 10 and -7. Because my leading coefficient is not a 1, this is just how I'm going to split my middle term. So I have 14c squared plus 10z minus 7z minus 5. On the first two terms, let me factor out a 2z out. So I have a 7z plus 5. On the last two terms, let me factor a negative sign out. So I have 7z plus 5. My factors will be 7z plus 5, 2z minus 1, and don't forget your greatest common factor to begin with. I'm going to have to do the second part.